Hello everyone, I'm Kimi. We're live. How's your day going? Today I'm super excited to give you an update about Energent.ai, the AI agent that help you think and do. Let me start by sharing my screen. Our product was launched about 4 weeks ago, and since then we give people a wait list to join. We see there are a lot of people queued up on the wait list, and the team are working hard to ship new features in the last couple of weeks. And today, I'm going to give you an announcement for one of the major updates we did for the last couple of weeks. The update we did is actually called multi-agent. And then if you have already received the invitation code, and then if you go to your app.energent.ai dashboard, you will see your version has already been updated to 0.2.1. And this major version update will introduce a new agent workflow called multi-agent. Think about you're building a company. The entire company won't be built by a single person. You have a CEO, you have a CTO, you have a bunch of engineers, marketing, salespeople. An agent system is the same. A single agent cannot get a great work done. You need a fleet of agents to do the work. And then after we bump our version from 0.1 to 0.2, we'll actually introduce this new thing, which is multi-agent. Now, when we actually, one of the things we claim our system is doing great is actually about security. I have a use case I want to show you guys today first to walk you through why Energent.ai is a secure system. And then after I showcase the use cases, I will go through the security architectures by showing you a system diagram regarding how we architect our Energent.ai backend to make this a secure system. Let's begin with the use case I want to show you. I log into Energent.ai, it's a website here. When you first come here, this thing may initially look to you just like a nano chatbot, but this is more than just a nano chatbot. For example, if I go to here, I can see my Energent.ai is actually trying to connect it to its computer. Just give it a second, its computer will soon be ready. In this specific task I want to give to Energent.ai to do, it's like this. You're given a paper. The paper is the very famous attention is all you need paper from Google. And then you're asking to do the following tasks. You have to extract all authors' name and affiliation from page 1. I want you to further search each author's LinkedIn URL on Google and click into each link to verify you're finding the right person by clicking their affiliation, especially who has a common name. And then at the very end, I want you to list all the author's name, affiliation, and LinkedIn URL in the table. Before we do this, I want to show you one thing first to make sure you can co-work with your app, with your Energent.ai's computer by actually log yourself in first. Why the computers or is still trying to log in to the system? Maybe let's go through the security backend first. When we build our backend, we take our customers' privacy as the first priority. When customer was interacting with Energent.ai, customer were using our front end app.energent.ai to log in. After they log in and then hit the traffic in our backend actually provision in a cloud provider such as AWS, Azure, or GCP. We can also do on-prem provision to your own secure private network. Assuming the stack is actually on top of AWS, Azure, or GCP, we actually take people's privacy as the first priority. None of the traffic is actually in a public network. All the traffic is actually in a VPC stack, and VPC stands for Virtual Private Network. Within a VPC, we have a bunch of clusters that managed by Kubernetes. Within one cluster, we have multiple nodes. And each node is actually the computing units. But however, a node is usually a very beefy instances. A node is actually accessible further through a pod, which is the ultimate computing unit, your virtual instances that we're using here. And usually in a node, it has more than one pod. And then when a user's traffic first hit Energent.ai's backend, will actually hit the cloud provider's gateway. The gateway will actually further forward the traffic into a secure virtual private network. It will get further forwarded to a Kubernetes cluster nodes pod. Usually a node has multiple pods running. You can think about each pod is actually the virtual computer, like a desktop. And then there are actually two kinds of security which really matters here. First is your connection secure from the front end to the back end? Considering we're actually using the gateway and virtual private network, this traffic is super secure. And then the second thing is whenever you are in a pod where your information be only accessible by you instead of other people or even people within the same node. The answer is yes. Each pod is actually built through a container, and it's containerized with isolated traffic, and this pod is actually dedicated to serve your needs. Now, with our backend architecture in mind, let's go back to our app.energent.ai website. Look like our computer is now ready. When you first go to the website, you will feel like, oh, this is just a nano chatbot. What's a big deal? But the magic is we believe the ultimate tool that every AI agent needs is actually a computer. And we do so by equipping every AI chatbot with not just the AI chatbot, but a computer on your left. Considering I'm going to do a task which have the steps. You're given this paper. And then this paper is the very famous Google paper, attention is all you need. I want the agent to do the following tasks. I want to actually extract all authors' name affiliation from page 1, search each author's LinkedIn URL on Google, make sure click into each link and verify you are finding the right person by clicking their affiliation, especially who has common name. And then last, I want you to list the author's name, affiliation, and LinkedIn URL in the table. But before I do this, because I used to work at Google as well, I want to see whether I am a common connection to this person as well. So the first thing I'm going to do is I'm going to log in my LinkedIn. I have my LinkedIn here. I'm going to click it. I will sign in, use mail. Let me find my LinkedIn account. I'm going to copy my email over. Oh, by the way, I'm actually using Control V here as a shortcut. And I'm going to get my password, and I'm going to hover here. And usually people hate to actually typing their password into the VM. You can do Control V here, or we actually providing user with a shortcut functionality. You can just do paste it. Okay, now I had LinkedIn. I had to sign in. And bingo, my LinkedIn is logged in here in this very secure virtual desktop. And now let's give it the prompt and see how agent can actually finish this task for me. Just again, the task is you're given this paper, and the paper is the attention you need. I want you to extract the all authors name and affiliation from page 1. Search each of the authors' LinkedIn URL on Google, and make sure you click into each link to verify you are finding the right person by clicking their affiliation. And then last, I want you to list the all authors name, affiliation, and LinkedIn URL in the table. And I'm going to hit send and let the agent go. While the agent is doing the work, we actually want to prevent our user from fighting the same control for the computer with the agent. And now if you're trying to take over the control of the computer, you won't be able to do it. But if you really think you know it exactly how to do it, you can actually interrupt it. But here I'm going to say no. Let's start to analyze the trajectory. It will say, okay, I will actually look at I'm going to download the paper. I'm going to extract author's affiliation. I'm going to search the LinkedIn, and I am going to let's start it with the first agent, which is the multi-agent system. It's a computer agent. And the computer agent first go to download the paper, I believe. Let's see whether the paper is ready. Look like this is a wrong URL that we have to fix because the paper should be in the downloaded folder, not the uploaded folder. But if I'm going to the files, I can clearly see the attention paper is actually here. And if I click this, okay, looks like it doesn't allow me to open it. I'm just going to click it here again. And looks like, okay, now the paper is actually downloaded in your computer. Okay, let's see what the next thing is going to do. Okay, the paper is saved. The paper is available. Initially, this is actually the planner agent, and the planner agent actually first handed over to the computer agent, and then computer agent actually downloaded the paper. Let's see what computer agent says here. Okay, computer agent finished doing its work, and it's actually handed over to the next agent, which actually I believe is actually the browser agent. And let's go back to the computer and see how it's going there. I think now computer agent goes to search on Google and then find the first person's LinkedIn page, extract the content from Ashish Waswani, and now it goes to the second person, Nam Shazir, doing Google search again, extract the content, and then this is coming in, and then this is this magic that you don't really have to do this LinkedIn scripting anymore. You can just give the task to AI agent, and it's actually doing that for you. And it is still going. Okay, while this is still going, I know we're short on time. I'm going to switch to another tab, which is actually a video I have for doing this task. So I'm going to play this video this time so you can actually see the entire works. This time is actually my co-founder Rachel's LinkedIn. I'm going to play it 10x so you can see exactly how that works in a faster speed. So this time Rachel logged in her LinkedIn here. I'm going to play maybe 15 speed. It go download the paper first from the website on archive. And then after the downloading is done, it's actually transferred to the data analysis agent. And the data analysis agent uses any parser to actually parse the documents to make sure it knows who are these authors. I want to actually do Google search. As soon as I know the author's name, it first search Ashish Vashwani. As you can see, the computer on the left is actually doing the search, and on the right, the agent is actually doing the work. It went for the second author, Nom Shazir, and then keep going for the third author. And all the way to the end. As soon as the agent think about it finishes tasks, it's actually handed back to the original computer control agent. And then boom, here is the results you have from the agent. It actually cross each of the person, give you the LinkedIn, and then also their LinkedIn is also on the left. If you want to actually further explore, you can explore yourself. It give you their name, LinkedIn, current affiliation, their education history. And to the very end, the agent confirms that it has done all the works and then hand it back to the user for the next round of the conversation. So just a recap of today's talk. Today, we give you the major update regarding Energent.ai that we launched 3 weeks ago. In today's work, we especially launching multi-agent. So this is not just a single agent system, it's actually multiple agents working together to get the work done for you. We showcase you our secure architecture regarding how our backend works, and then why we take users' privacy as the highest priority. We further show you a specific use case that it can actually helping you looking for the website, parsing the information, crawling the web, and then eventually compile that into a markdown that you can actually use directly. This is just a beginning of more features that we're going to ship through Energent.ai. So make sure you sign up at app.energent.ai today and claim your AI teammates. Thank you. And see you next week.